Hi there, I'm Kathleen Jasper, and today we're working through part 4 of our Praxis Math 5161. Today we are going to review a little bit about matrices. We're going to use proportions to solve problems. We are also going to work through polynomials and graph parabolas using our graphing calculator that you're allowed to use on the test to solve complex problems quickly and efficiently. Let's get started. All right, so you'll recall that last session, that was part 3, we went over matrices. Now, if you haven't seen that particular video, please go back and review part 3 because I'm going to do a high-level question involving matrices that I saw in a practice test. And when I saw it, I thought, my review of matrices may not prepare you for this particular problem. So I want to make sure that you're prepared for all kinds of problems. And this one I saw and I want to review. So if you haven't seen the video on matrices, and I believe it's part 3, please go back and review that. We're going to move right into this one, and I'm going to assume that you already have the knowledge that we talked about in the previous video. Remember, this is part 4, so there are 3 previous parts to this series, and you may want to go back and watch each one before you watch this one, okay? Now let's look at number 1 here. Which of the following is a solution set for the matrix below? And you can see I have some crazy answer choices here, and I have this matrices here that lines up to be a matrix that represents systems of equations, and we reviewed that in the previous video. So essentially, we're going to turn this into a system of equations, okay? Now, remember, when we multiply matrices, which is what we're essentially doing here, we're taking this top line here and multiplying it by this here, and then we're taking this bottom line here and multiplying it by this. And then this part here, we're actually multiplying this x and y by a scalar of 3. So we're basically distributing that 3 through the matrix, although I'm not sure if that's what you call it. Remember, I call things the wrong things a lot in these videos because remember, this is not my content area and this stuff is really hard for me. So I try to explain it the way I think about it in my head, but remember, what I'm thinking about in my head could be completely wrong. In fact, my husband tells me that a lot when I try to talk to him about the math. He's like, no, that's not what that means. But it helps me figure it out. Hopefully it'll help you figure it out. All right. So we are going to basically turn this system or this matrix into a system of equation. Let me just erase this so we can do it. All right. So let's turn this matrix into a system of equations. So let's start with this right here. We are going to multiply that by this here. So it starts off as 2x plus, so we do that here, plus a negative 1y. So we're going to just make that minus y equals, we're going to move this here, 3x. Okay, now we're going to move to this one here. We're going to multiply this by this here. And so I have 1 times x is x, and then I have plus 4 times y, which is 4y, and that equals 3y. That's how you do a system of equations with this matrix. Now, what I'd like to do now is basically move all of my variables over to one side of the equation, and that makes the other side of the equation in this situation equal 0, which helps me to figure out what types of solutions there are. I visualize it that way. You can also use algebra to move all of your x's on one side and all your y's on the other, but I don't like the way that looks. I like it to set up, in this case, equal to 0, and that's what's going to happen here. So I'm going to use algebra, and I'm going to move my variables all to one side. So if I do that, if I want to move this 3x over to here, I need to subtract 3x. What I do to one side, I need to do to the other, and that gives me negative x minus y equals, and in this case, it's 0, okay? Because there's nothing else on the other side of that equal sign. Now, same thing. I want to subtract 3y here, subtract 3y here, and I get x plus y equals 0. Now, in this case, notice how this works out. I have a negative x minus y equals 0, and I have an x plus y equals 0. These mean the same thing. Negative x minus y is really x plus y. Now, when this happens, and typically when you see something like this, and this is the correct answer, by the way, when you see something like c in the answer choices where you have negative c over c, where c is any real number, and then you see this kind of thing setting up, that's going to be your answer, okay? So pay attention when you see something like answer choice C. Now, let me just show you what that means. Basically, you're going to, this is any number. So this could be -5 and 5. Let's just make it -5 and 5. It could be -10 and 10. It could be -3 and 3. But let's just do that where C is any real number. And this is going to be your X, and this is going to be your Y. Let's see how that works. So if I have -5 here, if I were to put that in, that would be minus -5, which makes it a +5 minus, this is a Y here, -5 equals 0. Is that true? Yes, it is. That is true. And let's do, again, let's put a -5 here, and that's a positive, so it's going to stay -5. And let's put a 5 there, plus, because I'm using this part right here, plus 5 equals 0. Is that true? Yes and yes. And it would be true if I did it for 10, if I did it for 13, if I did it for 250 million. If I put -C and C and made them both the same number, basically one is negative and one is positive, and my, setup, it looks like this, then C is going to be the answer. Now they just use -C and C, but it could be -K and K. It could be -D and D. It doesn't matter. They're just using these variables because X and Y are already taken up here because we're already using that in the system of equations and in the matrix. So just be on the lookout for something like that. Now, if we were to plug in A and B, it wouldn't work. They would not equal 0. And when it says there are no solutions, that happens when you have something like, after you do this whole situation here, you have -3 equals like 4, and it's clearly not correct. That is not what happens. That's when there are no solutions. But in this situation, -C and C, where C is any real number, we can see that if we plugged in right here any real number with -C and C, we would get the correct answer, which in this case happens to be 0. All right. So just wanted to go over that because we didn't cover anything like that as in depth on the first video we did on matrix. So I want to make sure we cover that. Now let's move into the algebra piece that we're going to be talking about today. Number 2 is going to be proportions. This is a little bit of a difficult proportion because you're only given a little bit of information here and you have to find the rest of the information. So first I want to look at my answer choices, and I can see that they're all in percentages. I notice that this is a pie graph or a circle graph, whatever you want to call it. Let's read the question stem. What percent of the amount she spent on food was spent on takeout? So we're looking for a piece of, the puzzle here. I have to read the entire question to figure this out. I always like to work backwards. So I always start with my answer choices and work backwards, especially when it comes to word problems and longer problems. So let's read from the top now. The circle graph below shows Sam's monthly budget. Sam spent $800 on rent. Of the amount she spent on food, 90 was spent on takeout. What percent of the amount did she spend? What percent of the amount she spent on food was spent on takeout? All right, so this is a classic word problem with only giving us a little bit of information, and we have to figure out what's going on to get the rest. And in this case, you would use a proportion to solve this. Proportions are your friends. They help you solve so many word problems when you're only given a little bit of information at a time, okay? So let's take a look here. I'm talking about food and rent, and I have 32% is on food, and I have 40% on rent. And then I have dollars here. I have $800. So the way I want to set up this proportion is percent over total dollars equals percent over total dollars. Now, you could do total dollars over percent equals total dollars over percent. Remember, it needs to be matchy-matchy. So percent over dollars equals percent over dollars, or dollars over percent equals dollars over percent. Make sure it's matchy-matchy. Whatever you have on the top, you have on the bottom. Otherwise, the proportion won't work out. Let's do it this way. So let's start with rent because I have the rent total dollars here, and I have the rent percentage. So that's good. I have that piece of the puzzle. So the percentage of rent is 40.40 or 40%. And then we have total dollars is 800. And that's going to equal the percent of food, which I have here, 0.32 or 32%, but I don't have the total dollars spent on food yet. So what I want to do is cross multiply and solve for x, and then I will have the total amount I spent on food. All right, so let's do that. When I cross multiply, I get 0.40x equals 0.32 times 800, and that equals 256. I'm not done yet. Divide by 0.40, divide by 0.40 or 40%, and we get x equals 640. So I know that food, the total amount was 640. Well, that's very helpful now because I'm not done yet. I am not done with this problem. That's just another piece of the puzzle that I have figured out using a proportion. Now I need to figure out what percent of the amount I spent on food was takeout. Well, if I spent $90 on takeout and my total amount I spent on food was $640, simply divide 90 by 640 and you get 14 or 0.40 something something, which equals 14%. And that is going to be A is the correct answer there. So proportions are your friends when you only have a little bit of information and you're trying to figure out more pieces of the puzzle. Sometimes you'll have to do 1 or 2 proportions to figure that out. But just remember, once you get here, you're not done yet. You have to apply that to the actual other piece of the question here. And this one happened to be about the food. All right. So use proportions to help get through some of those problems. All right, let's look at number 3. So I'm going to look at my answer choices here. This is a long problem, so let me go to the question stem just to prepare myself, because that's how I like to do things. If Tawanda and Jesse continue to grow at these rates for the next several weeks, after how many weeks will they be the same weight? So this is a rate of change question, and what we want to figure out is when Tawanda is equal to Jesse, because we're looking at when they will be the same weight, even though they probably have different weights now and they're probably growing at different rates. Let's read the rest of the question. 2 children, Tawanda and Jesse, are the same age with slightly different weights. Tawanda is 70 pounds and is growing 1/4 a pound a week. Jesse is 67 pounds and growing 1/3 of a pound a week. And then it says, if Tawanda and Jesse continue to grow at these rates for the next several weeks, when do they equal the same weight? After how many weeks? So again, we want Tawanda equals Jesse. That's all you have to do. You have to take the equation for Tawanda and the equation for Jesse and set them equal. So let's do that now. So we have Tawanda is 70 pounds and she's growing 1/4 pound per week. Let X be per week, all right? And that's going to equal Jesse, who is 67 pounds, and we're adding, because he's growing, 1/3 pound per week. Notice that they're in slope-intercept form, right? This is a slope-intercept problem because rates of change are the slope. Either the rate of change is going up or the rate of change is going down, right? Just a little side note. So now all I want to do is get my x's on one side and my non-variable numbers on the other side. So I just want to use algebra to do that. So what am I going to do? I'm going to subtract this 67. It's going to cancel. I'm going to subtract 67 and I get 3. And then I'm going to subtract 1/4x and I'm going to subtract 1/4x. Now you could just put in your calculator 0.333 and then minus 0.12 or 0.25, sorry. But these fractions are easy for me. All I'm going to do is find a quick common denominator here, and I get 3/12 and 4/12, and when I subtract, I get 1/12. So I get 3 equals 1/12 x. Now I want to get this x isolated by itself, so how do I remove the fraction? I multiply both sides by 12, and I get 36 equals x, or x equals 36. After 36 weeks, these two will be the same. All right, now, then they'll eventually change because they're growing at different rates, but at 36 weeks is when they are the same weight, okay? So easy peasy, all you have to do for the rate of change, trying to figure out when they'll be the same, there's lots of ways in which this is presented. Just take both equations, set them equal to each other, solve for x, and that's your answer, okay? All right, let's take a look at number 4. If 5/7 is expressed as a decimal, what is the digit in the 23rd decimal place? I used to hate these problems, but I really think that they're super easy now that I know how to do them. My husband taught me how to do them. So we're going to take 5/7 and express it as a decimal. So all I'm going to do in my calculator is I'm going to take 5 and divide it by 7. And when I do, I get 0.714285. And then the pattern starts to repeat again. All right. Now, the main thing you want to do is count how many digits there are before the pattern repeats again. So I have 1, 2, 3, 4, 5, 6. This repeats 6 digits before the 71425 starts again. All right. So there's 6 digits in that pattern. Now I'm looking for what's in the 23rd decimal. So ideally, what I would do is take 6 and divide it into 23, but it doesn't go evenly. But 24 does, right? 6 goes into 24 4 times, right? Or 6 goes into 18 3 times. So we know that after the 24th time, this 5 hits. On the 24th time, this 5 hits, and then on the 25th time, it goes back to 7, 1, 4, and it goes on, okay? So what I would do is I would say, okay, at the 24th place, we're at 5. So at the 23rd place, we're at 8 because I want to go back 1. So that's where I would get 8. Now, you could also say, all right, 6 goes into 18 3 times. We end up here at 5 on the next round, right? The third round. And then you could go, so this is 18, and then you could go 19, 20, 21, 22, and then that 8 would be 23. However, I think it's easy to go up 1 and backtrack 1 to 23rd. Both ways work. 8 is the answer. All right, let's take a look at number 5. Now we're getting into parabolas, and a lot of people get, agita when they talk about parabolas or stress, but they actually become fairly easy on this test, especially because you have a graphing calculator. Remember, you can use that graphing calculator on any of these questions, and it's going to make your life a lot easier. I'm going to show you how to do that. Now for this question, you don't need the graphing calculator. All we're going to do is use a simple formula to solve this problem. Now I can see here in my answer choices, I always want to go there first. I can see it's in equation form, x equals, and it says the graph of the axis of symmetry of a parabola y equals 4x squared plus 10x minus 24 is best described by which of the following equations. So we're looking for the axis of symmetry. Now let's talk about what the axis of symmetry is. When you have a parabola, and I'm just going to draw a random parabola, and it's not that good of a parabola, the axis of symmetry is the vertex and then the line that passes through it, right? Because if I were to fold that parabola across the axis of symmetry, it would be symmetrical, right? So we have the vertex, which is the bottom point of the parabola in the right in the middle. I don't know if that's the technical term, but it's right in the middle at the bottom. And if I were to fold the parabola over, that is the axis of symmetry. Now, basically what we're finding here is the vertex. And the way you find the vertex is you take negative b over 2a. That's all you have to remember. Negative b over 2a. Now remember, this is a, this is b, and that's c. Remember from our quadratic equations and the reverse FOIL that I told you about that my husband says is not a real thing, but it's a real thing to me. So we're not going to do any of that. We're just going to use this equation here, negative b over 2a, to find this vertex. Now, when I take negative b over 2a, b is 10, so negative b is negative 10, and then I have 2a, 2 times 4. Okay, so that becomes negative 10 over 8. And when I put that in my calculator, 10 divided by 8 is 1.25, but it is negative, so it's negative 1.25. And you can see b is x equals negative 1.25. So that's how easy it is. And you can see I actually drew this parabola, I guess, somewhat correctly, because this, let's say this is 1 and this is 2. You can see that that is where the axis of symmetry would be, right there, the vertex, but that's an easy way to do it. Now, you could take this equation here, or this polynomial, I should say, and you could put 4x squared plus 10x minus 24 into your graphing calculator. It would graph this parabola for you, and then there would be a point on the calculator where it showed the vertex, and you could look at that. But putting all that in and possibly messing up, is, for me, harder than just plugging in this quick formula, especially when it's easy peasy numbers like this. Now, if they were crazy numbers and you really wanted to use your calculator, you could totally do that. But I just did it this way because it's easier. Now, let's take a look at another one. Same thing here. We're not finding the axis of symmetry, we're finding the vertex, but it's the same formula. We're going to use negative b over 2a. When I do, so this is A, and this is B, and this is C. When I do, I get negative 12 over, and I have 2 times 3, which is negative 12 over 6, which equals negative 2. So that is as simple as it gets there. I wanted to show you both ways because you may be asked to find the vertex or you may be asked to find the line of symmetry, and both are done by using this simple formula here, negative b over 2a. So burn that in your brain and remember that when asked about the vertex or the line of symmetry. All right, so now things are getting a little more complicated. You can see that we have a 4th degree polynomial here, which can tend to stress people out for sure. But remember, you have a graphing calculator. It is an online graphing calculator, but I recommend you use it for problems like this. Let's take a look. At how many points on the xy plane do the graphs below intersect? All right, so this is actually very, very easy. First, we have a 4th degree polynomial here, and that means it's going to be some sort of zigzaggy line like this, depending on how many real roots there are, and it's going to have 4 movements, so 1, 2, 3, 4, so it wouldn't have that there, right? And let's just say 1, 2, 3, 4. Let's just say the line goes here, right? And then you're going to have some sort of straight line here. The slope is positive because that is y equals mx plus b form. So there's going to be some sort of line that goes up this way. Now, it's probably not going to look like that, but you're basically going to have to figure out where do they intersect. Now, the way you do that, let me erase this terrible picture of the xy plane. Now let's do this on our graphing calculator, okay? Basically what I'm going to do is I'm going to put this in and I'm going to put this in and I'm going to hit a button and I'm going to get a graph and I'm going to count how many times they intersect. Let me show you how that's done. All right, so I'm in my Word document right now because I just want to copy and paste for the sake of time, but you will have to type it into your calculator. So what you're going to do is you're going to take this piece right here and I'm going to copy that. And I'm going, you can see I've already been working on my calculator. I'm going to choose this button here. That allows me to put in more than one equation, I guess I would say, maybe polynomial. I don't know. I'm not sure what it's called, but it allows me to do 2 things. This little button right here. See my hand? Now this software is called Mathway. You can get it online. I did the upgrade, the paid version, because there's more things I can do, but you can also get it for free online. But remember, you're getting a graphing calculator on test day. So you can do this in your graphing calculator. Choose this button here so you can graph 2 equations. Put my first one in there, all right? Then I'm going to take my line here, and I know this is a line because it's in slope form, and it's got there's no x to the 4th or x to the 3rd. It's just x. Right? So I'm going to grab that and I'm going to put that in here and I'm going to hit this little button here. You would hit enter on your calculator. It's going to ask me, what do I want to do? I want to graph this so I can take a look, and you can see I get this nice graph. And when I click on it, I zoom in on it. Look how easy that is. Now you can see I have an intersection here, 1. I have an intersection here, 2. I have an intersection here, 3, and I have an intersection here, 4. These intersect 4 times. So it's simple. Just go back to my answer choices and you can see my answer is E. Now on this test, I believe you'll only go to D, but I just threw in a bunch of different ones because I wanted to make it a little bit harder. But your answer is E4 because they intersect 4 different times. All I had to do is use my graphing calculator. Took me like 10 seconds. That's it. You want to use that graphing calculator on test day. All right, let's take a look at number 8. This is an average rate of change question. You will get this. This is all about functions. And you can see that, to my distress, I'm not going to be able to pick A, B, C, or D. I'm going to have to write in the answer or type in the answer on test day. So you will get questions like this. So make sure you're prepared for, writing in the answer rather than just A, B, C, and D. You won't get many of these, but you will see a few on the exam. All right, let's take a look. Here's the question. What is the average rate of change in f over the interval -1, 3. All right, and then I have this function here, f of x equals x to the third minus x to the fourth. All right, this is the formula you're going to use. You're going to do the function of b minus the function of a over b minus a. Now be very careful. The function of b is when you take, and this is a, and this is b. The function of b is when you take b and you plug it in to this function and get the answer. And the function of a is when you take a and you plug it in to this function and you get an answer. Now, a and b are just -1 and 3 respectively. So if I were to fill in this equation here, I would have, let's just put it over here, I would have 3 minus -1, all right, which is 4. But I'm going to leave it like that, 3 minus -1. Just bear with me for a second there. Now I need to figure out what is the function of b here. Well, let's take b, which is 3, and plug it into the function. So the function is x to the third minus 4x. So if I have 3 to the third, because I'm plugging in this 3 here, minus 4 times 3, I get 27 minus 12, which equals 15. So the function of b is actually 15. b is 3, but the function of 3 is 15. Now let's look at the function of a here. So what am I going to do? I'm going to take this -1 and I'm going to plug it into the function here. So I have x to the third minus 4x. So I'm going to take -1, I'm going to cube it, and I'm going to minus 4 times -1. When I do that, I get -1 because -1 times -1 is +1 times -1 is -1. And then I have a -4 and then another negative here, which actually becomes a +4. So what does that become? That becomes 3. So my function of a is 3. A is actually -1, but the function of a is 3. Now I'm going to work out this fraction or this problem here. So I have 15 minus 3 is 12, and I have 3 minus a -1, which is really 3 plus 1, which is 4. 12 over 4, which you may do something like that, but when you do that, 12 over 4 equals 3, right? So this equals 3. The average rate of change for this interval is 3, and that's how you do it. All right, now another way you might see intervals, you know, the problem we just did was an interval function problem. This is also an interval function problem. Let's take a look at the answer choices. You can see that we have kind of a range where x is greater than or equal to 0, x is less than or equal to 2, and then it goes on down the different answer choices there. So let's take a look at the question. Over which interval does the function have a negative rate of change? All right, so we're looking for, when we say a negative rate of change, we're looking for a negative slope, right? It's going negative direction, down, okay? If it said which one has a positive rate of change, the slope would be going up this way. But in this case, we're looking for a negative. So we're looking for a negative slope there. And then, you know, you could go in and do what we did before here. Let's take a look at this. This interval, let me rewrite it because it's kind of messy, is this interval is -1, 3. So basically this is x is greater than or equal to -1, x is less than or equal to 3. That's how that interval is, okay? Because when you have these brackets here, it means -1 and 3 and everything in between. Now, the way it's presented in this question is a little bit different. Here you have the intervals lined up this way. Now, the easiest thing to do here is to throw this into your graphing calculator. You could try to work all of these out just like we did in the one before, but that's going to take way too much time. Go ahead and put this in your graphing calculator and let's see what happens. All right, so let me go ahead and enter this into my graph calculator here. Now I only need one graph. I don't need a bunch of graphs. And when I do, you can see that it pops up a graph right here for me. Now, let's take a look at this. You can see that there are some changes happening in this line. You can see that it goes positive here, then it goes down negative here, and then back up to positive. Well, we are interested in the negative portion of it, right? So here it is. Right here is when things are negative, right around in this area. So we're looking at about 0, 1, 2, 3, a little bit into like 3.5, but then when we get past 3.5, it starts to go back up again. So the interval really should be no bigger than 3.5-ish and no smaller than 0, because if we're in the negatives down here, notice that the negatives have it going up. So we want to be right in this area here. This is the range of numbers we're looking at. All right, so let's take a look at our answer choices, and you can see that A is x is greater than or equal to 0, and x is less than or equal to 2. Looks like that's in my range. Let's go back and check, and you can see x is equal to 0 or greater, right? Starts to go down. And then it says x is less than or equal to 2. Look at that right there. Is that a negative slope? Is that a negative rate of change? Yes, it is. So it turns out that A is actually my answer, but I'm going to just show you why B, C, and D are not the answer. Let's take a look at x. X is greater than or equal to -2. X is less than or equal to -1. All right, let's go there. -2 greater than or equal to and less than -1. So you can see that we're right around in this area here. And what's going on there? Well, the line is going up in that situation. We want a negative rate of change, not a positive. So B is out, and C is out for the same reason. X is greater than or equal to -2. So it's somewhere over in here, greater than or equal to -2. And it says here, less than or equal to 0. Again, we're in this range right here. Right here, still a positive slope. Let's discredit D. X is greater than or equal to 4 and x is less than or equal to 5. Well, let's zoom out just a little bit. That would put us right in this range here, right in this area here. And what's happening to the slope? It's actually going up. So that would not be the answer. So let's go with our answer A. Looks good. And again, you wouldn't have to really double check all of them. If you wanted to, you could. But now that you have that graphing calculator, just look for the slope as it's going down, grab those coordinates. A is the best answer. All right, and finally number 10, which seems to be very complicated, and if you tried to do this by hand, it would be very complicated. In fact, my husband and I did do this problem by hand last night, and I wanted to murder it. So I'm just gonna show you how to use your graphing calculator, because why spend 10 minutes factoring a polynomial when you could just put it in a graphing calculator and get the answer very, very quickly. So we have, this is a 5th degree polynomial, and to factor it by hand, you would have to group these and do the AC method, and you run the risk of messing up, which I did like 100 times last night. All you do is take this polynomial, throw it into your graphing calculator, and you're looking for how many real roots does the polynomial have. Now let's talk about real roots. Remember, when we're talking about real roots, we're looking at how many times the polynomial crosses the x-axis, okay? So you can see for this one, there's 1 real root, 2, 3, 4, and in this case, there would be 4 real roots. But I don't know yet. I need to figure this out because sometimes there are imaginary roots. Remember when I said, I believe it was, I think it's part 2, where we talked about imaginary numbers. When you have a negative, let's just say it's -9, the square root of -9, that actually equals an imaginary number because you pull out the I and you get 9, right? Or the square root of 9i. And so we're looking for real roots here. And if you were to factor this by hand, you would actually get 2 imaginary roots. And we don't want to factor it by hand because you could totally mess it up. But you would actually get 2 imaginary roots, 2 ways in which this happens, and then you would get 3 real roots. But let me show you how this works in your graphing calculator. Okay, so I'm just going to throw this polynomial into my graphing calculator. There it is, x to the 5th minus 9x to the 3rd plus 14. I'm going to hit this little go button. I'm going to hit graph. And when I do, you see this graph that comes up. Let's click it and zoom in. Notice this is my x-axis. Let's zoom out just a little bit so you can kind of see the polynomial or the parabola. It is going all crazy. Look at this little weird situation here. That actually happens because of the imaginary roots. But notice that it crosses the x-axis 1, 2, 3 times. So this has 3 real roots. That's all you have to know. We can get into why, and if you factored out the polynomial, you would see when you set each section equal to 0, some will work and some will be negative square roots, which turn into imaginary roots, and they're asking for real roots here. But really all you need to do is take that polynomial, throw it into your graphing calculator. If you're looking for real roots, count how many times it crosses the x-axis. In this case, we can see 1, 2, 3 times it crosses the x-axis. In this case, C is going to be my answer, 3, and I solved this in 5-10 seconds. If I were to try to factor this out by hand, I could make all kinds of mistakes. All you have to do is take the polynomial, throw it in your graphing calculator, count how many times it crosses the x-axis. That will give you the number of real roots. In this case, it's 3, and we can move on with our lives. All right, so that concludes part 4 of our Praxis Math 5161. Remember, the problems that we worked on today are down in the description below. You can download them and work them out yourself. Please hit the subscribe button if you like our content. Also, hit the notifications button so you're notified when we upload new content. Let us know how you're doing in the comments, and have an awesome day.